Student, in this topic you are going to learn variation of resistivity with temperature of metals, alloy and semiconductor. Here you are going to understand what will happen if temperature increases in the case of metal. What will happen for resistivity with rise in temperature of alloy and rise in temperature for semiconductor. Number A, you understand, number first is variation of rho with rise in temperature for metals. Example, Cu copper. Let us take the example of copper. For copper, here we are taking rho for resistivity, and here we are keeping temperature. Then this is 50 Kelvin, this is 100 Kelvin, this is 150 Kelvin. That is it, Kelvin K. And here we are putting resistivity. Let this be 0.2 and this is 0.4. And the value of resistivity in the case of power is 10 to the power, this is 10 to the power minus 8 ohm meter. Let us take this resistivity. Then if you increase the temperature, then you find that resistivity of metal directly increases. This means that temperature and resistivity have direct relation. So the graph will be a curved line. This is the graph curved line for copper Cu. What you are finding? You are finding resistivity is proportional to temperature. This means that with rise in temperature, resistivity increases for metals such as for copper. Number B, take the example for alloy. So variation of rho with rise in temperature for alloy. Example, nichrome. Here we will draw the graph, and the graph here again we take temperature T, and the value for temperature will be taken at high because it is alloy. It is 200 Kelvin, it is 400 Kelvin, it is 600 Kelvin. In Kelvin, it is taken in Kelvin. And here the resistivity will taken in low, so let it be 1.00 at this point. Let this be 1.10, let this be 1.20, and rho resistivity is taken here in micro ohm centimeter. This is in micro ohm centimeter. Resistivity is taken in micro ohm centimeter. So then what happened? The graph is a slanting graph like this. See, this is the graph. This is a graph nearly a straight and slanting graph from this point. This shows that resistivity vary negligibly with rise in temperature for alloy. Resistivity varies negligibly for alloy with rise in temperature. But what about in the case of semiconductor? So here it is variation of resistivity with rise in temperature for semiconductor. Semiconductor such as silicon, Si semiconductor, Ge germanium, and for carbon also, carbon, C for carbon. The graph have curved nature, and this curve rho is here resistivity and temperature T is here. This graph shows that resistivity and temperature have inverse relation. This means that rising the temperature decreases the resistivity for silicon, germanium and carbon. You must memorize this. This will help you in board examination as well as in comparison examination. And if you are understanding physics, then do like, subscribe and share my videos. Thank you.